Hi guys, good morning. So in the last session, we went with the VLAN ACL and we started with the HSRP. Okay, so this was the lab we have to do. Okay, the comments we had seen that okay, how to configure the HSRP, right? So let's directly jump into the lab and we will configure this lab here for HSRP. Start all the notes. So let's meanwhile these routers are starting. Let's go with the configuration. So first of all, R1 configuration. Line console 0. Logging synchronous. And then host name R1. Interface 80/0, IP address 11.1.1.10.255.255.255.0. No shutdown. G0/1, 12. Then interface loopback 1, IP address. Then in this portion, we will run HSRP. Okay. In this portion, we are supposed to run HSRP here. HSRP 100. Okay. So I'll say router HSRP 100. Then I'll say network 8.8.8.0. Network 11.1.1.0. Network 12.1.1.0. This is the configuration for R1. Then we have switched to line control 0, logging synchronous, host name, switch to interface gig 0/0, IP address, and this will not accept IP address because this is L2 interface. So I'll say no switch port. I'll say IP routing to enable the routing traffic. No shutdown. G0/1. This will be 11.1.1.1. This is done. Then I'll say router HSRP 100. Network 192.168.12.0. Okay. Sorry, 1.0. network 11.1.1.0. And one more thing I'll say here, passive interface 3.0/0. That means I don't want to form any HRP neighborship between switch 2 and switch 3 from here. Okay. So for that, I'll say passive interface 3.0/0. This is done. Same configuration for switch.
Sir, even switch router also we need the passive interface gigabit 0 command, or if,
No, only switch, because between switch
uh,
2 and switch 3, I don't want any HRP neighborship through the LAN side.
okay, because of switch we are given this command, right?
Not because of switch. The requirement, I have a requirement that I don't want to form a neighborship directly between switch 2 and switch 3.
Oh, okay, got it,
Okay.
got it.
Yeah.
Thank you.
Then here, this is switch 3. Host name is switch 3. Interface gig0/0 will be having an IP address 1.2, and Z0/1 will be having 12.1.1.2, 1.0, 12.1.1.0, and passive. This switch, all the ports I'll configure as a port pass. Okay. So you can say on the LAN switch, let's enable configuration. Terminal, host name, LAN switch, interface range Z0/0 to 3, spanning tree, port pass. Okay, this is all the configuration required. Now, why these PCs are not starting? Okay, started. Now let's take access. So first of all, R1, switch 2, switch 3, R1 access, switch 2, switch 3, LAN switch, PC5, PC6. Okay. So I'll go and configure IP addresses in the PC5 and PC6. This is 1.10, this is 1.20. So I'll say IP 192.168, 1.10, 255, 255.0. And you can see, like I said, I have to set one gateway. Between these two, I have to configure one gateway only. I can configure one gateway on one PC. But I know that, okay, if I will configure this gateway and this switch goes down, I'll not have communication. If I configure this one as a gateway and this goes down, I'll not have a communication. Problem is there. So to avoid the problem, we are configuring what? HSRP. And for HSRP configuration, what we will be using? We will be using the virtual IP as a gateway. Okay. So instead of showing you with the Z1 1/1 or 1.2, I will directly show you with the HSRP configuration with 1.254. That is fine with everyone. Because in CCNA, you have seen this thing that, okay, this is the PC. If I'm using this one as a gateway and this goes down, definitely I will not have communication. I'll have to go and change the gateway to 1.2. Then only I'll have communication. Correct? Okay. Guys, online people fine? If I directly go with the virtual IP?
Yes, yes.
Okay. So I'll say here, gateway 192.168, 1.254. And here on the second PC, we will configure the IP as 20. This is clear. On the LAN switch, we will configure the port pass feature. Now, one by one, we will configure the devices. Copy, This is switch to configuration. Copy. This is switch 3 configuration. Copy. This is LAN switch configuration. All the configurations are done. Now, the HSRP neighborship should come up. So we can see two neighborships are there with 11.1.1 and 12.1.1.2. So that means your R1 is becoming neighbor with switch 2 and switch 3. That is totally fine. Okay. Now we will do what? We will configure HSRP here between these two. So HSRP will be configured on the LAN side interface. That is Z0 by 0 interface. So on the switch 2 interface gig 0/0. Okay, this is the interface. Here I'll say standby 1 IP and whatever the virtual IP you want to configure 192.168.1.254. Done. And same command I have to give on the other side also. Interface gig 0/0. Done. Both the sides I have given command. Now see what will happen. They will select a standby or active role. Okay, so by default, they will check the priority. Priority will be a type. Then they will check the highest interface IP address. This side we have .1, this side we have .2. So which one is having the higher IP address? .2. This guy will be becoming a active. So you can see HSRP state change. This guy changed from standby to active, and this guy will be in the standby. Okay. So let's see. Do show. You can see this guy is in the standby. So if I say do show standby, now you can see that the state is what? Standby. What is the virtual IP address? .254, and automatically one virtual MAC address is also there. Right? Okay. What is the hello time? 3 seconds. Hold time is 10 seconds. What is the preemption status by default? Disabled. Who is the active router? 192.168.1.2. What is their priority? 100. Who is the standby router? Local. That means I am the standby. What is my priority right now? 100. What is the default priority? 100. This thing is clear, right? Okay. Now switch 3 became what? Switch 3 became active router. Okay. And let me write the configuration. Now check PC file. Is it having communication with 8.8.8.8? Having a communication. If we trace the path, to which router? 1.2, which is switch 3. Correct? All the traffic is going via the active one. Correct? This is clear. Okay. What if the active goes down? If I shut it down, I'll power off this one. So this guy is down. Now, if this guy is down, the switch 2 should change state to active now. Do you see? From standby to active. This is clear. And still we will have communication. You will see. We still have the communication. And if we check from where the communication is happening, through 1.1. Understood? This is clear. Now, what if the switch 3 will come up again? If switch 3 will come up again, switch 3 will not automatically become active. Why? Because preemption is disabled. Because preemption is disabled. So now this is starting up. So you see, automatically this guy became standby. This guy automatically became what? Standby. If I say show standby, you can see it will say active router is who? 1.1. This guy is the active router and I am the standby. This is clear. Now, if this guy will go down, this guy will become active. Clear? Now, let's say I want that, okay, this guy switch to should only be active always. Okay. So what we can do, we can change the priority. How? Let's say I want that, okay, only switch to should be active and always only should switch to should be active. So I'll say interface gig 0/0 standby 1 priority. Okay. And you can see I can set the priority value. Higher the priority, more preferred. So let's say by default priority is 100. I'll change this priority to 110. Okay. And then what I'll do, I'll enable the preemption also. I'll enable the preemption also. So once I will enable the preemption, what will happen? See, right now this guy is active switch to. Now let's bring switch to down. Switch to, I'll bring it down. Switch to is down. Okay, I forgot to write the configuration. Okay. We didn't write the configuration. So when it will boot up without any configuration. That means the new configuration that we did about priority and that configuration will not be there. So I have to restart it once. Online people, any doubts so far?
Sir, without any packet drop, it will switch over to
Yes.
that one.
Yes.
No packets is drop.
No packet will drop because this guy, as soon as this guy will become active, so this guy will send a ZR to inform everybody about the new MAC address.
Okay.
Okay. There can be few packet drops while transitioning because this guy will wait for 10 seconds. Hello time is 3 seconds and this guy will wait until 10 seconds. So 5 to 6 seconds, there can be packet drop. Okay.
Okay.
Yeah. So right now you can see who is active. Switch 3 is active. And switch 2 you see change to standby. So I want that, okay, switch 2 should always be active, even if it is going down. So when it come back up, it should be active, okay? So I'll say configuration terminal. Then I'll say interface gig0/0 standby 1 priority 110 standby 1 PM. Okay, now the configuration has been written. And you can see as soon as I change the priority and I enable preemption, automatically this guy changed state to active. That means you can say, let's say there is somebody joining later with the higher priority. So that guy will become what? Active. Okay. Now see here, this guy is active right now. And you can see switch 3 is what? Standby. Now switch 2 goes down. So switch 3 should again change the state back to active. Back to active. Now, what if the switch 2 will come up again? This guy is having higher priority and preemption is also enabled. So when this guy will come up, you will see switch 3 will change back to standby. We wait for switch 2 to come up. You see, this guy changed state back to standby. Okay. And switch 2 here is changing back to active. This is the meaning of preemption. Clear? Now, in HSRP, you can also configure authentication. Now, what do you understand with the authentication? What do you understand with the authentication? That means the authentication means like the HSRP agreement will be done between the routers only if the authentication matches. So HSRP supports MD5 authentication. Okay. So see here, how do you configure? So first of all, we will configure keychain, and then you can give a name to the keychain. Let's say I'll give it HSRP. Okay, then key and key ID, let's say key ID is 1. Okay, then key string. So key string is the password that you want to give. Let's say I want to give the password as 12345. Okay, or we can give, let's say, password as CCNP. Then once this key string is created, go to the interface gives 0/0, and then I'll say that standby one authentication, and you can say which authentication is supported, either plain text or MD5. So I'll say I'm going with the MD5 authentication. Then it will ask me key string or keychain name. So my keychain name is, I'll say keychain, and name of my keychain is what? HSRP. This is clear. Now what will happen? The authentication will not match, and you will see bad authentication from 1.2. Okay. So this side also we have to configure the same thing. Enable configure terminal chain HSRP E1 key string CLP interface gig 0/0 standby one authentication and lead by chain HSRP. Now the authentication will match, and they will decide who will become active, who will become standby. Switch 2 will become active, and switch 3 will become standby because of higher priority. Okay. Switch 2 has higher priority, that will become active, and this guy will become standby. This is clear. Online people, any doubt? Yes or no?
Sir, how they will check each
How they will check?
other when other is live or not?
So they are sending hello messages, right? You can track this. You capture the packets on V0/0 interface. Every 3 seconds, there will be a hello message. See here, HSRP hello. Both active router and standby router, they are sending hello. And in the hello message itself, you can see
Okay.
they are sending all the authentication information also. See here. This is clear.
Yes.
So the port number you can note down for HSRP is 1985 based on UDP. HSRP uses UDP port number 1985. Clear? Yes or no? Okay. Now, few things we see that sometimes we see active, speak, standby. Then here, this side, we have the listen state. Okay. Earlier, if you check, we have the listen state. So what are these states? Okay. Let's talk about HSRP states. First of all, authentication. So how do you configure authentication? You say keychain, and here you give a keychain name. And then you say key and key ID. Here you give the password. And by group number, authentication, MD5, keychain, keychain. This is how you configure HSRP authentication. Then HSRP states. Number one, initial. Okay. While configuring HSRP, This is the first state. Then listen. The router or switch will start listening hello packets. Speak. Here. Active. Standby. Election takes place. Standby. This is the backup one. And active. This is the one who is forwarding the traffic. This is clear. These are the HSRP states. Note it. Yes or no?
Sir, the HSRP authentication needs to configure both active as well as
Yeah,
standby, right?
both correct.
Okay, same configuration.
Same configuration. Note it. Now, similar to the HSRP, we do have protocols like, VRRP and GLBP also. So GLBP majorly you will study in your CCI interface. Okay, so right now and there is not much of a difference if you want to try the configuration. Okay, so first let me talk about the difference between HSRP and VRRP. Difference between HSRP and VRRP. Configuration wise, only the difference in them is what? Wherever you use the keyword standby, in place of that keyword, you use VRRP. That's it. Okay, in the place of standby, you use VRRP. And same with GLBP. HSRP, VRRP. Now, number one, this is Cisco proprietary, and another one is this is Cisco proprietary. This is open standard. Okay, this is the first difference. Then second difference, here we have the active and standby state. So here the states are what? Active, standby, and candidate. While in VRRP, the same thing is known as master and backup. So here, one active, one standby, and remaining all candidate. Here, one master, remaining all backup. This is clear? Yes or no? So HSRP uses multicast address. Like on what is the multicast address they use for communication? 224.0.0.2. And this side multicast address, it will use is 224.0.0.18. Clear? Here, hello time is what? 3 seconds. Hold is what? 10 seconds. Here, hello time is 1 second. And hold is what? 3 seconds. That means VRRP is comparatively fast. This support plain text and amplify authentication. Does not support authentication. Okay. Preemption disabled by default, and here preemption enabled by default. These are the differences. Okay. Okay. Noted. Right. Whatever the comments are there, similar comments. The comments will be same. Only instead of standby, we are asking. Okay. This interface name, VRRP, group number, IP, virtual IP. VRRP. Okay, if you want to configure the priority, preemption is by default enabled, so no need. Group number, priority, and priority. Clear? Online people, guys, clear, right?
Yes, sir.
Now, quickly, I'll remove the configuration from HSRP configuration, and I'll do the VRRP configuration. Interface with 0/0 to show run interface. No. Done. And same comments I'll apply there also. And one more state you can note down, that is disabled. So you can say done. Disabled means HSRP is not enabled. I'll say VRRP 1 IP 1.254, and I'll say VRRP 1 priority, and priority, let's say I'll give it 110. Same command I'll give this side. VRRP 1 IP VRRP 1 priority if you want to set, and let's say this is 90. Done. So you can see this guy became master, and this guy will become backup. So we were using the command show standby. Here we will use show VRRP. Similar output, state is master, Preemption is by default enabled. Virtual IP address, virtual MAC address. Advertisement interval is 1 second. Master router, okay, and master down interval. So it will wait around 3 seconds. This is the VRRP configuration. By default, priority same. Priority and all those things will remain same. Clear? So this is your FHRP concept. Understood? Online people clear? Yes or no?
Yes, sir.
Okay, so now L2 security is remaining. So tomorrow we'll complete your switching. Okay, so make sure you guys revise about port security, DHCP snooping, and dynamic app inspection. 3 topics we'll do tomorrow. Clear? No. Okay, guys, then I'll see you tomorrow. Have a good day.
Yes, sir.